steel construction meet with the theme of the challenges that we face and what can be the proposed solutions. Indeed, steel, especially in the construction sector, as a construction material, has quite a few challenges, some of which I'll be discussing in the brief next 20 minutes, which basically have accrued from my experience in working in this industry for the past 29 years. In fact, the moment I speak, I'm also at the moment designing for an integrated steel plant at Dolvi and also major works for Tata Steel. So out of that experience accrues what I'm sharing with you today. So without wasting much time, let me get straight into some of the challenges and some of the solutions which I thought it would be very prudent to discuss today with you all. Just to give you a quick summary, can we have that? Yeah. So these are the basically points which I'll be harping on tonight. So it is, the first thing is life cycle cost. Why? The most important challenge that steel faces, which I find in the industrial sector, is cost, the upfront cost. It loses to RCC in the upfront cost, and many cases, originally proposed steel structure is later replaced by a RCC structure during the construction stage. So that's a very important point which I want to discuss, because the knowledge of the life cycle cost of steel is very, very important to be propagated amongst the industry so that people can really correctly choose that what should be the construction material ultimately, which is applicable for the proposed application. The next important point is, there's also a major, I think there's a big presentation after this also, but I would like to touch upon that. That is the popularity of composite construction in India, composite design and composite construction. We need to propagate and rise composite construction and composite design. Why hasn't it happened yet? We'll discuss. Third being, a very, very important point, because I believe we have designers, builders, architects, steel producers, everybody in this forum. So this is a very, very important point, because I'm facing this problem at the moment. It's a burning issue for me. That is development and training of skilled construction personnel. No matter how well I design on paper, it will always remain on paper unless it can be actually be built on ground the way I wanted it to be in the design. So that's a very, very important point. Next is, in fact, last Friday, Shantanu was also there with me. We were in a seminar organized by JSPL. Parallel flange beams, yeah, but it is not a question of any company. It's not a brand name. Generally, parallel flange beams existed much earlier in Europe, IPE sections, HEA, HEB, which much later came to India. So we need to know the efficacies, the advantages of using parallel flange beams in steel design and steel construction. Then comes high tensile steel. Presently, everybody is talking about using high tensile steel. But why and how and where? The correct knowledge, the correct application of high tensile steel will make it popular only if we indiscriminately use 550 MB yield strength steel everywhere and anywhere. Ultimately, what will happen, that the cost will overrun the budget. It might so happen if high tensile and mild steel are not at the par cost wise. So we need to know correctly where high tensile steel and its usage will give you the maximum advantage. Then comes very, very, very important point which I often face in the industry nowadays, and while addressing, by introducing myself, I have been working with IIT Mumbai very closely of the last days in developing OSDAG, which is a connection design module. And I have been working with the people who write the code, Professor Satish Kumar of IIT Chennai, Meera Raghunandan of IIT Mumbai. Why? Because there's a huge ignorance in India presently regarding limit state method of design. We have, after the IS 800 2007 was brought out in the market, replaced our age-old working stress method of design by the latest limit state method of design. But India and the designers and the constructors have not parallelly gone to that level. Many of them have, but many of them have not. So it has to be a mass change. So that's a very important point, the limit state method of design, which is a quantum change. It's a paradigm shift of total thinking. We have to know that, otherwise we can't make steel popular. And lastly, I would want to talk about a bit about the space frame structures, because unfortunately, maybe during the course of this presentation we will see a lot of space frames, etc. But unfortunately, speakers after me will also confirm my point. The BIS hasn't brought out the Indian code on space frame design yet. So till now we have to depend on the foreign journals, literatures, and international codes. So can we go to the first point here? So talking about life cycle analysis. So basically what it is, in India, in the Indian context especially, I'm trying to limit my speech to the Indian context, because outside India, steel is already being used in abundance. But in India, money and upfront cost becomes a huge point whenever it comes to implementation. So what do we find? Yeah, indeed, the cost of steel structures is higher, similar to the similar concrete structure, in the initial stages, the upfront cost. But considering the total lifespan of the structure, the reusability of steel, the salvage value of the old structure, the maintenance cost and the frequency of maintenance required for a steel vis-a-vis a concrete structure, the life cycle cost of the structure should be worked out. And if we can impress upon the users that particular thing, then I believe steel will be much more popular. Before coming to this gathering, actually we did work out a comparison, live comparison in the running project that I'm at the moment designing. What we did was, we designed two buildings, two-story, to keep it simple. Though I am a specialist in industrial structure, complicated structure design, but to keep it simple, a two-story, basically its use was as electrical control room, ECR, what we say in our industrial norm, or substation building you can say. We designed it with completely concrete. We designed it with completely steel. Completely steel by means I'm saying even the slab I took it as checkered plate or plate. So it was steel through and through except the foundation. So the foundation cost I have kept aside for this comparison. So the superstructure for the steel part and the superstructure for the concrete part we compared through the life cycle cost analysis based on the Indian code 13174, part 1 and part 2, 1991, 1994, part 2. Okay. So what we found, that obviously what we knew all the way, it came out to be the initial cost of steel though was 25% higher for this kind of a building. The basic plan dimension of the building was 30 meter by 15 meter. 30 meter, 15 meter, G plus 2 plus roof. So basically 2 floors and the roof, G plus 2. But you'll be astonished to hear that the life cycle cost was 30% lower for steel. Why? Because the lifespan and the salvage value of steel structure was 40% higher. So, if we have this kind of information and knowledge with us, then it's obviously we can tell it to the clients and the people who are using steel, who will be investing in steel for the longevity of the structure, for the lifespan of the structure, because anybody won't build a building for 20 years or 25. Though, as per IS 875 Indian codes, we have the lifespan 50 years, 25 years. But what is our experience in the industry? That anybody building a steel plant related structure, would he demolish that structure asking me, sir, the 50-year lifespan is over, so let's break it down, build another building? Nobody will do it. They will do what? They will revamp it. Maybe revamp it for higher, greater capacity, or keep it at the same capacity after doing a health study. So, it is very prudent to know this, that for life cycle cost analysis of a steel structure, it will come out for even a small 2-story 30 by 15 building, 30% life cycle cost is less for a steel structure than the corresponding concrete structure. Take next slide, please. You see this circle of things, structural steel material, then we have the construction stage, transportation to site, then we have the use, the intended performance, use, it fulfills its service life, it's repaired or revamped, then it's deconstructed, if at all, again recycled into the structural steel material. So it's a circle, it's a continuous circle. So this is the advantage of steel, but if we all can show the people who matter in this way, perhaps steel will find its use more abundantly and more popularly. And this is as per the relevant Indian code, which I have mentioned at the bottom. So this is a very, very important point, which I took it at the very onset, because this is the fundamental point which prevents usage of steel in India at least. I have seen this for the past 29 years and even seen it today. When my client always asks me, please compare and give me a comparison report. Okay, so we go to the next point. The next very important point which I feel is, it will be taken up by a speaker later on also, that is composite construction. Now composite construction, I have kept this as a challenge. Why? Because composite construction, we know that it's good, we know that it's fast, but it's not done up to the level it should have been done in India by now. Why? To me as a designer, I had certain points which I'll share, but what is basically steel composite construction? That we have the slab and we have the steel decking and then we have the beams below it. So as if the slab with the steel decking forms and the beam forms a T. The slab and the decking, the compression flange, and the steel beam below it, the web. So we utilize the advantage of steel being able to take tension here and concrete being able to take compression, because we know concrete is weaker in tension. So the next one, we know about the composite construction, but it hasn't yet been utilized to the fullest potential in India. Some of the advantages of composite construction, though this gathering I believe knows it, but still, just to hop on some of them, it definitely does reduce the self-weight of the structure because it's a combination of steel and concrete. Due to the increased ductility, which is provided by the steel decking and the steel beams below it, composite construction it performs better, and more so in seismically affected areas. At the moment I am designing structures in a seismic zone 4, so where we have to do ductile detailing. Okay, so ductility, it performs better in seismically affected areas. As compared to RCC structures, the composite structures, most importantly, take less time to construct. Now, in the industry, my experience till date is, my clients only allow composite construction in the last 2 points, when these last 2 points here mentioned are in vogue, which is what? One, if I can impress upon them that this will be constructed in much lesser time, because time is money. Time can be directly translated into money. If you save time for the client, you save money for the client. So that's a very important aspect. And the second, the last point is, for many steel makers who themselves roll the steel decking, they can do away with the conventional shuttering, use the steel decking, save time, as well as use their own produced material. By that, they reduce cost further. Now, I'll show you a comparison in the next slide. Can we have the next one? Yeah. So this is actually taken from a paper. You can see this, that the research till now has shown that at This particular slide is not for the industrial sector, because I thought many people from here will be at the residential, commercial, building, design, etc. So this particular slide should be interesting, that for G+12 buildings, it has been seen commonly that it's even Stevens, means normal RCC structure and composite structure will be even Stevens, marginal savings at par, so to say. Above G+12, if you go for an increment of 4 floors, G+16, G+20, G+24, there is an increment of 5% in savings for each 4 floors. That is, G+16 you will get 5%, for that above that 10, and above that 15. It's why the reason for this is very obvious, because composite construction is mainly used in the floors. The plan area remaining constant, you are going up, right? So the number of floors, as it increases, your savings increase. So more the number of floors, more the number of savings, because more the use of composite design and construction. So having said this, initial stigma which I find is definitely cost, because one producer who is not producing himself the steel decking, or a particular client, a particular person who is who has to buy the steel decking, because it may be costlier from the normal shuttering, but then time is money. Though this particular graph which I have shown here does not take into account the savings that you accrue from saving the time. It is just the cost, the basic cost. This particular graph doesn't speak about that, time translated into money. So after that, we move on to the next important point which I said. Yeah, so development of skilled and trained labor. Mind you, this is not a very generalistic statement. Though I have written like this, I intend to explain what I mean to say. Because it's not a general statement, because we have skilled labor, we have trained labor, no doubt about that, but for specific applications which we need to do for betterment of construction and design in India, there I find a lack of training and skill. Namely two, I'll just, at this forum I'll just say two, and the last point I'll come with that regarding space frame. That is, one is bolted construction. In fact, Mr. Sajjan Jindal also wanted me, when I met him before designing his plant, he wanted his entire plant to be bolted. Fine, it's very easy. Obviously, it is correct for him to envisage and plan accordingly, because outside India, everywhere you will see that. It's bolted construction, it's much easier, faster, but how to ensure quality? You just cannot conceive a bolted construction and make it at site. You have to do certain steps, take the pain to ensure the quality of the bolted structure. And if you are not aware about that, you are going to have a structure which is weak. Why? We all know that generally in bolted construction, obviously, we use high tensile bolts. High tensile bolts, when used in construction, bolted structure do not match at site. So what do the people generally do? The contractors generally, or in many cases, they don't do also. That is, they gas cut the hole to adjust the bolt. But unfortunately, in a gas cut hole, enlarged hole, the high tensile bolt doesn't work. It loses its efficacy. It doesn't take even 1 ton of shear. So we have to do with these ignorance, they have to be rimmed. Mismatch can always happen, but the holes have to be rimmed and adjusted. So just to give you an example, because I am facing these particular problems day in and day out, because at the moment I am designing a bolted structure, a huge, not a structure, a bolted integrated steel plant, primarily bolted. Again, it's not fully bolted, primarily. Why I say primarily? Because bolted structure will not find its advantage in many places where it's vibration prone. Where the structure is vibration prone, it's better to have a welded structure, because bolt will tend to loosen with time. So it's very important to have in India skilled personnel. Even the best of the best cannot claim that they are at the moment building perfect bolted structure. But many are doing a good job, but most aren't. Then comes the use of tubular sections and hollow sections. Square hollow sections and rectangular hollow sections. We all know, architects, designers here, that these are very popular sections to bring aesthetically pleasing structures. But we need to be very careful regarding the workmanship. Our recent experience in other integrated steel plants have been appalling at times. We have found that most of the contractors, though claimed to be adept to the use of hollow sections, they weren't. And some of the connections, the debacle happened in the connections, were appalling. So, out of experience, I'll request this forum to generate another forum where we can address this very, very important issue that designers, just producing mere design on paper does not suffice. The theme being Steel Construction Summit, so if I want to give the focus on the construction part, we need to be able to transfer that design into actual construction on ground. For that, if seminars are required, training is required, we have to do that. Spend time, spend money, we have to do that. It's a very, very important point. Next, use of parallel flange beams. Kindly indicate if we are within my time. 2 more minutes. Okay, I'll run fast. Give me 2 plus 2, 4 minutes, I'll run fast. Parallel flange beams are quite popular, always were quite popular in Europe. It came very late in India, but they definitely are more advantageous than our conventional MB sections. This does not, I think, need any further justification to this extremely knowledgeable forum. You can have a look at some of the technical points which I have mentioned. To say the least, there are much, much more technical. Most important is ISMB, the tapered flanges. Now, at the moment, only for monorail carrying, hoist carrying beams, ISMB sections are used. Because for the hoist or the monorail, the particular wheel profile matches the tapered section of the flange. Otherwise, almost ISMB sections have been replaced by parallel flange beams, and definitely they are extremely advantageous for connection point of view as well as capacity point of view. Then a very important aspect, I'll just spend a minute on this because this is a very burning issue in India. Everybody asks me, are you using, even Mr. Sajjan Jindal asks, are you using high tensile steel? And I say, yes, we are, but we are not using it indiscriminately. We are using it with proper discretion where it finds its advantage. All of us know that high tensile steel, basically, in structures which are deflection prone, serviceability is the criteria, there the geometrical property of the section basically governs. No matter what I provide, no matter how much high tensile I provide, how much higher yield stress I provide, the stress doesn't govern. So, we should identify those areas where high tensile applicability can indeed bring about a change in tonnage, reduce the tonnage, and give us a better design. Apart from serviceability criteria, there is another very important area where high tensile should be used with proper caution and proper discretion. That is, structures where fatigue stress is the governing phenomena, where we all know in industrial structures that there are EOT cranes. EOT cranes travel on gantry girders, EOT crane girders or gantry girders to say. Those particular girders, they are subject to repetitive loading, cyclic loading, that is the structures which are more prone to dynamic loading and cyclic loading, they are subject to fatigue stress. So there also it might not find its advantage. So we should definitely be cautious about the use, not indiscriminately, but with proper discretion. Then only the cost factor of a normal structure with mild steel and that built with high tensile steel will be at par or advantage. And also we should be remembering about the compatible electrodes of welding and inventory management and site. If you are using both kind of steel and the same sections, that is also very important. 250, 20 thick, 350, 350, 20 thick. So inventory management also is a very, very important point. Next. And I've already said at the very onset, there has been a paradigm shift of design fundamental philosophy in India, from the working stress method to the limit state method. But this IIT and other institutions also, they need to propagate. We are all trying to propagate so that entire India comes up to the challenge and meets the challenge and does the design with the limit state. Now at the moment we find some people follow, but many people don't. But that doesn't happen. Limit state, everybody asks me, does it give lesser tonnage? That is not the point. The point is limit state is a much more exhaustive method of design, and working stress was, compared to limit state, a comparatively inexact method of design. This is much more comprehensive design. Obviously, if we do comprehensive design, correct design, then we will reach our goal, and it's not always directly translating to lesser tonnage, but it's not compromising the correctness and the comprehensiveness, the totality of the design. So it's a request all to propagate the use of limit state method. Next. Yeah, this is the last point. I've already taken up some more time, I'm very sorry. This last point being, I'm sure we are going to see quite a few structures and presentations on space frames, which are definitely the thing in the market. But unfortunately, BIS, we have requested to them in the forum also, to the Undersecretary Steel, Mr. Sunil Barthwal, I was there in the INSDAC forum, that the relevant Indian standard has to come out. Now the designers in India, they have to much more be dependent on foreign journals and international codes. Like it is the niche design, patented design of this Maro joint, you might have seen in the Birsa Munda airport at Ranchi, and also the Chandigarh International Airport. Quite a few airports were mentioned by Avneet at the very onset. This ball and socket kind of a joint, which is actually called the Maro joint. The design is almost patented by the Chinese people, and also we have Canadian code, but then the Indian code needs to imbibe these things. Otherwise, it's very difficult for us to design, and that to design it correctly. And again, skilled personnel. Whenever these things are being built, mostly the personnel, the laborers are coming from abroad. In fact, in Tata Steel also we made that circular wagon tipler covering shed, and also in Dolvi, where the designing steel company, the Chinese, Juzhou Steel, they brought people from there to assemble. They trained some of the people, Indian people, but most people came from abroad. So the Steel Construction Summit should also propagate that the construction skilled personnel should come up with the latest technologies and meet the challenges. Thank you so much.